So question 11, what is the Lewis structure for selenium trioxide? Okay, so for the total number of valence electrons, selenium has 6, and oxygen also has 6, but we have 3 oxygen atoms, giving us a total of 24 valence electrons. So first, let's draw selenium as our central atom. And then I'm just going to draw single bonds to each of my oxygens. And if I were to draw in all of the lone pairs on my oxygens, it will kind of look like this. So this gives us 24 valence electrons, except all of these oxygens would have a negative charge, and we want a neutral compound. And also our selenium doesn't have like a full octet. So we are just going to make double bonds from each of our oxygen atoms. So selenium is one of those examples where it can have more than a full octet. So this is why we are able to draw double bonds all around. And now we have a neutral molecule, and everything has a full octet. In the case of selenium, there's more. And let's see what the junior tutor said. They have their step-by-step guide. Make sure the atoms follow the octet. Strictly have 8 valence electrons. Minimize the formal charge if possible. And now they applied it to the question. Oxygen follows the octet rule strictly. Moreover, since it has 6 valence electrons already, it would typically create 2 bonds only to completely fill its valence shell. Oxygen is unlikely to be the central atom because it creates a few bonds only. Selenium, on the other hand, can exhibit expanded octet and create multiple bonds. So this is, given the explanation in step 1, the logical arrangement is having selenium in the center. And then they showed how all the double bonds can be formed. And they included the equation for formal charge. So if we were to calculate the formal charge of all the atoms, it would just be 0. So the solution is